guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Where to start on this one? So guys, we're dealing with an xforce 1kW, which is a 10 pill. Now this amplifier showed up over here months and months and months and months and months and months and months ago, and after talking with the guy that owns this box, he's really struggling to power this thing. I don't know how he's going to be able to do what he's wanting to do with it with the power supply situation he currently has. I'm just going to fix it and give him some advice. Now he went on to tell me a story about his dealings with trying to get this thing repaired. It's been back a couple times to get repaired, and each time he gets it back it's starting to go away on him, and I think what's causing it to go away is the power supply issue. First things first, let's talk about this. This is the first one I've ever seen where they had multiple strands of wire coming out of the amplifier. I don't know what was happening here, but they've got the wire strands broke up on the inside to help spread out the ground around the inside of the cabinet. The other thing is that there's two different fuses here. You're losing more amperage by trimming the wire back like this than you are by going through, that you're saving yourself by going through two different fuse blocks. See, this collar that's in here actually comes out. You can back that out and then it's actually going to be big enough for it to receive this wire. But the smashed eyelets and stuff, this is going to cause you more amperage loss than what you would have had if you would have just gone with one fuse block. But I'm going to take these off so I can test it and run it and know that it's safe. I'm going to send these back with the amplifier when we're done. And now I don't know how much longer you're going to be able to stay on a 110 outlet. He's got his radio, his driver, and this amplifier all on the same 110 outlet, all on the same circuit. Which, if somebody was to take a voltmeter and plug it in a wall, clip, I'm sure that they'd be able to measure that the line voltage is dropping down to like 100 volts or less. So what we got here is a burnt pill, and another burnt pill, and then a burnt pill, and then another burnt pill, and another burnt pill. So you can see all the 10 ohmers are smoked, the output combiner rings all melted down. So we're going to go through and we're going to make it just a little bit more efficient. We're going to change out these power leads. We're going to test all of these caps, and depending on where these caps line out, we're going to put metal clads in their place. That'll help it have a better chance at life. It really will. We're going to take all the transistors out and we're going to replace them with the HG transistors, since we can't get crosses for the RFP 100s, the PP 100s. Even though we know where they come from, we can't get data sheets that make any sense to where we can cross these lot numbers over with other parts that are currently available on the market. So unfortunately, that drives us to the point where we have to change all the transistors. Anything that's good, I'm going to send back with the box, and I'm also going to send all the bad parts back. So this guy gets everything back. I don't need these or need to have these transistors for any reason. So anywho, I'm going to do my dirty bit on this. Now, I got a lot of ground to cover this weekend, you guys. I got a lot of work to do and a whole lot of people I got to make happy. I spent most of this last week working on one of the very last new build projects I have left in the queue. I got it completed, but I need to get some of these repairs done. And I got a whole stack of stuff I got to get done before the next week, so I can go over and drop them all off and do the antenna party over at Bakerman's house to get his stuff back on the air. So I need to get with it. Well, gentlemen, on that note, we shall return. I'll be back about halfway after I get it all stripped apart. See you, bye. Well, got the amp all stripped down, and exactly half of the amplifier is bad. So one transistor out of each 2-pill section went bad. Now you guys understand that this is an amplifier, and this is an amplifier, and that's an amplifier, this is an amplifier, and so these are sections, right? So you have a 5-port combiner and a 5-port splitter, and it takes a signal from each one of these and sums them together or splits the signal apart evenly. Okay, so one transistor out of each 2-pill bank or section went bad. And normally when we see that, that's a voltage issue. Okay, normally if it's from a high SWR or a heat thing, you're going to see randomly like this transistor fail and this one down here fail, and then maybe one over here. But when you see one out of every other transistor in the box go bad, what has happened is the amp got hot, low voltage, and the fields collapsed on each one of the transistors. And how each 2-pill section works, you have one transistor, we'll say this one here, is going to rectify the positive side of the waveform, and then the other one's going to rectify the bottom side of the waveform, okay? So technically, we're talking 27 times a second, 27.0 whatever times a second. The box is only half on at a time. Okay, so you're only presenting half of a load at one time, because one transistor's on, the other one's off. Push-pull. One's pushing the positive signal, and the other one's pulling the negative signal. Pushing this. Okay, so when you have a catastrophic failure and it's uniformly the same across the whole amplifier and the transistors, that says something to us, the builder. Now, let's say that I've been doing this for more than 2 or 3 days, which I have been. I've been doing this now for, well, you guys are exposed to the last 5 years of my life. Anyhow, I've been tinkering with this stuff since I was a little kid, since I was like 16, 17, and I've been in radio since I was 12. But you start accumulating a little bit of working knowledge on things. So let's just say in the past, I've had people come to me and say, man, I was running my 4-pill on a 50 amp power supply, but I just kept the dead key low. It wouldn't hurt it, right? Wrong. No. Not enough power supply. The voltage internally dips quite heavily, and it ends up costing usually a person hundreds and hundreds and hundreds of dollars to have it fixed, where the power supply might have only cost them $200, and the repair ended up costing them $5 to get the right size supply to do the job. So, on that note, I've marked all the bad transistors with a little black dot, and they are toast. The other ones have incredibly low gain. They're about ready to fail also. Okay? I honestly don't believe this is a tuning issue or a construction issue. Each one of these output caps is 1,100 or 1,096. This one's a 1,096 puff, which is within spec. Each one of the little side capacitors are supposed to be 120, but these are 130s. They all come in at 125, and I know that because I had to pull most of them because of the way this thing was put together. The 330s on the input transformers, they hardly ever go bad. I'm not going to bother checking them. Now what I'm going to do is I'm going to wash it, clean all the schmoo out of each one of the holes, go back through with a Q-tip and clean out each one of the pill pockets, and we're going to put the transistors in it. And we're going to put it back together. We're going to rebuild the combiner ring, which is burned up. We're going to check the input and the output tune, and I think this thing is going to be out the door and back down the road to this guy. This thing came here, and I wasn't able to get to it quick enough, and the gentleman ended up taking the money that we was going to use on the repair and did some other things with it. So he called me up like an honorable person would do and said, hey man, I had to spend the money. Can you put the thing up on the shelf? When I get the money back together, I'll give you a call. I said, awesome. Great. I love that. I'd rather people be transparent with me than have me go and invest all the time and the energy into doing the repair and then tell me after I'm done and I've got my money wrapped up in it, say, hey, I ain't got the money to pay you, so I'll get a hold of you in 2 months. Yeah, that's when I charge people money. This thing here, I just set it on the shelf. And so he called me about a week ago and says, man, get on it. Now, I've had a lot of stuff going on the last 2 weeks, between the break and everything else. So we're getting back in the swing of things, and I had to finish up some other projects before I could come hit this thing up. So he's super impatient. He really wants to get his box back. He's had to wait a couple months. I feel bad for him, but in the same breath, I'm glad that he was honest with me, and I'm glad we're here getting this done. So I'm going to go in here, my giant pack of HGs. This is what they come with when you get quantities of 100 or so. They come in lots like this. I'm going to grab a couple transistors out of here, 10 of them precisely. After I get this whole thing cleaned up, we're going to put it back together and see how it runs. And then we're going to go and make some adjustments on it from there. So I shall return. So where I left off, and let me clarify in that last segment, is that I got to thinking about this last night. You got one transistor on, one transistor off. And I don't know what happened, but whatever happened, every single one of these transistors failed at the same time as when they were all on. So I don't know if a light switch got flipped on, or somebody turned on a washer or dryer, or the oven got turned on and the line voltage on the house dropped just a little bit. But the voltage got so low, it's what popped one transistor out of every 2-pill section in here. It's a common problem, so I know when I see this present itself, I know that that's what's caused it, is that we've got a voltage issue feeding the amplifier. Now, I know that I can sit here and I'm going to rail on this, I'm going to rail on this, I'm going to talk about it and talk about it. And as soon as this guy gets this box, he's just going to hook it up and run it. And it'll probably pop again. But I've got it covered and I said my piece about it. It makes me feel comfortable on the inside. So, just wanted to show this real quick. All the transistors have been replaced, and that's what the solder work is supposed to look like. Clean, flux-free, no globs of goo on it. And the reason I show this is because usually when guys send an amp out to get it repilled, when it comes back, it's just held together by chicken poop solder joints. Now this guy, he's been a little sketchy. I think he was thinking that I wasn't going to ever work on his amp. I don't know why. Very untrusting. I mean, it's only like I've got 2,700 something examples of my work ethic out there at this point, and another 1,000 or so plus in private videos that aren't made public. But that's the way he was acting. So I want to make really sure that I document every step. So now we're not going to put these little poo butt 1 watt, or not even 1 watt, they're half watts, flame resistors in. We're going to put 5s. Your output combiner ring, that's what's left of it. We're going to replace it with 5 watt resistors. Hey babies. We're shooting a video, sweetie. Say hi to everybody.
Hi guys, sorry.
That's alright, no, I love you.
Love you.
So anyhow, should have to bring me my cable spooling device. We're going to replace this with 5 watters and make it all like new. And then we're going to run it with the tuning section that's set in it now. This setup here, which I'm not a fan of. But it does work. It's worked in a million boxes, but I'd rather take all these out, measure them, and then put the exact value in there that's needed, and then put a board in here to support this. And then I had some guys ask me one time, how do you go about tuning the output section if you can't unsolder the tube here? Well, there's 2 points of movement. You got this one, but xforce likes to use this solid copper bar here, so I don't worry about adjusting this. I go back here and I unsolder the tube and I can slide it back and forth. I don't know why that was so hard for everybody to figure out, but that's what we do. So let me put the flybacks in it, and then we're going to put the swamp resistors in the back of the combiner ring, and yeah, when we return, we'll be hooked up and running. Bumpity bump bump, bumpity bump, bumpity bump bump, bumpity bump. Okay, so this is a little cluttered, but this is what we got to work with. We've got our DC amp ring here to show me how many amps it's going to draw. Over here we got our voltmeter at 14.41. Then here is a 1,000 watt slug in PEP. Here is a 1,000 watt in average and a 5 watt slug in reverse. So we've repilled it, put it all back together, tested it. Just a very small test, and I'm going to show you the test that we're doing here. So we're going to key the drive radio, which is a 955. Put about 20 watts peak drive into it. We turn the amp on. Pulling 120 amps at 13.8 volts. And we're making about 750 watts peak. So now we're going to disconnect that. Trying to make a point on the amperage consumption. You guys haven't caught that theme yet. And the whole point behind this is that I strongly feel the reason this guy's stuff keeps blowing up is because he's starving it for power. He wants it to do 3 grand, but he's running it off a couple 110 power supplies, which isn't all necessarily bad. I just don't think it's possible. Okay. So we're going to turn the 10 pill off. We're going to run the 2 pill into it. This is a bench 2 pill. We're going to put about 400 watts of drive into it. Let's make sure we can still see the amp meter. We cannot. The high dollar fancy RG400's in the way. That'll work. 240 amps worth of draw out of the straight 10 pill, but it's pulling the power supply down to 10 volts. Okay, so we don't know what we're doing for power. We're burying the average meter and we're burying the peak meter. So now we're going to go to 2x. Over 1,000 average in 1900 and some jism. 210, 220 amps. So now, let's run this up a couple volts. We're going to go to 15.8. So when we come down to operation, it'll be at 13 something. Okay. We're burying every needle that we got here, except for the reflect. So we're going to pull our 1,000 out. We're going to put the 5,000 in its place in average. We're going to click this down to 5x. So now this meter here is 5,000 watts. That's 5,000 watts in average. Amp meter, voltmeter, and we're running at about 14.8. With 400 watts of drive, we're getting 2,800 out of it and about 1,500 bird. And we're pulling about 158 amps peak to produce this power. And we're running this off 2 separate supplies. I'm running this off the bench supply, which is 5,600 amps, and then we're running this off the 1,000 amp supply. So there's no limitation in amperage. Seeing 25 to 26. Now I haven't tuned it yet. This is just straight from the way xforce has it tuned. The input tune looks good. The output tune can give us a little bit more. So to see 26 strong out of this box, we're pretty damn close. Now we've got no uneven heating in any of the sections. Mylars are hot. No heat in the input tune and no heat in the output tune ring or combiner ring. No heat on the input splitter ring. Everything is heating up and cooling down evenly. So at the end of the day, amplifier is working correctly. The drive that might be put into this thing is going to vary from here to there. I know the voltage and the amperage is going to make a big difference. A big difference in operation down the road when it gets to this guy's house. So I got to mention that because right now technically I'm done. I repilled it. I changed out all the weak parts and put good parts in their place. And it's running like a raped ape now. So let's re-verify those numbers real quick. Now it flight hopping up's got me a little bit concerned. So guys, now what I'm going to do is I'm going to tune it, and I'm going to play with it for a hot second. I don't think that we're going to get that much more performance out of it, but let's see what we get. On that note, I shall return. What I want to show you is there's, right here is this output capacitor that we're going to be looking at right here. 2 of those. Now, I don't know if the customer wants to go and do the expense of changing out those caps, but I wanted to show this to you guys real quick. We're going to drive this with the 20 watts of drive again. One two audio. You can see those caps heating up pretty aggressively, and you can see them throughout the whole. You can see them throughout the whole amp. You see all those little glowy orange dots that you're seeing there in the background. Those are all the caps throughout the whole box, and you can see the heat starting here at the top of the transformer and then moving up into the capacitor. So I got to run that by the customer to see if this is something he wants to do or not, because it does add quite a bit of expense. Each one of those caps is about $6, and plus the ride to get them here to change those out. And this guy has told me a couple times. Okay. So with the 2950 hitting it, seeing about 2,500 watts out of this thing. Let's scoot over here, and we're seeing about 260 amps worth of draw. All right, 2,500, 2,000 bird, or 2,500 and about 1,500 bird or so. Now we're going to change radios. We're going to go to the 955, which isn't the best bird radio in the world. You're going to see the bird power fall way off, but the peak power is going to come up because we're going to drive a 90 watt radio into a 2-pill instead of a 20 watt radio. So we'll see a little bit more power out. Just seeing the average numbers drop off. We're getting 2,800 out of this thing, pretty consistent. And that's just with a 2-pill hitting it. So, tomato. The point is, it's fixed. It's fixed right, and it's going to run well. Now we can get you the right power supplies and get you set up. I don't think that this thing is going to give you any more problems. Mr. V, when I talk to you on the phone, we're going to talk about the capacitors, because I'm not going to consider this one done until you say send it. So, gentlemen, I'm going to cut the video off here. This is normally where I say, and I'm the biggest mud duck in Idaho. Well, guess what? I am the biggest mud duck in Idaho, but I'm going to let the customer look at this, and the only thing that's going to change between now and when it ships is if we're going to change out these caps. This one here, this one here, this one here, this one here, and this one here. Because these are not metal clad, and they're getting hotter than friggin' crazy. And what will happen is the heat in these capacitors will eventually break the caps down, and they'll lose their ability to swamp the transformer. And when that happens, the tune on this box is going to go haywire, and you might end up having a bunch of bad parts again. Now, yes, the fans might help keep it a little bit cooler. Yes, I'm not going to argue about that, and they might help. But these things are getting stupid hot. I mean, like 180 degrees is what I was showing you, and that's just within 2 or 3 very short keys. So, Mr. V, I'm going to give you a call on the phone right now. And gentlemen, I'm out of here. I'm going to go on to the next project. So, we're done. Moving forward. Moving on. Appreciate y'all tuning in to watch me repill and repair this little Blue Label xforce. Gentlemen, my name is BB. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Take a minute. Click subscribe if you like what you've seen, and if you want to, come send me a friend's request on Facebook and follow along. I'll see you guys. I gotta go. Bump, bye.